Hello everybody. In this session, we will solve a numerical on economic load dispatch neglecting transmission losses. So this numerical is asked in GATE 2015 exam in set 1 for 2 marks. This is a problem statement. Consider the economic dispatch problem for a power plant having two generating units. The fuel cost in rupees per megawatt hour along with the generation limits for the two units are given below. C1 P1 equal to 0.01 P1 square plus 30 P1 plus 10. 100 megawatt less than or equal to P1 less than or equal to 150 megawatt. C2 P2 equal to 0.05 P2 square plus 10 P2 plus 10. 100 megawatt less than or equal to P2 less than or equal to 180 megawatt. The incremental cost in rupees per megawatt hour of the power plant when it supplies 200 megawatt is. A few things we should understand here. What is meaning of this thing? So here C1 in bracket P1, it means that C1 is a function of P1, and C2 in bracket P2 means that C2 is function of P2, because operating cost depends on the power generation. Second thing is that here limits of P1 and P2 are given. So minimum limit of generation for P1 is 100 megawatt and maximum generating limit is 150 megawatt. P2 minimum generation limit is 100 megawatt and maximum generation limit is 180 megawatt. So we have to solve the problem. We have to determine the value of P1 and P2, and we need to check whether the values that we have obtained by solving the equation of P1 and P2, whether they are falling in this particular limit. If they are violating the limit, then we have to adjust the generation to either minimum limit to the maximum limit, depending on whether generation is less than the minimum or more than the maximum respectively. How many unknowns are there? There are two unknowns, P1 and P2. So we require two equations to solve these two unknown. So one of the equation is given in the data itself. Here they have mentioned that the incremental cost in rupees per megawatt hour of the power plant when it supplies 200 megawatt. Means together they are supplying they are supplying total power of 200 megawatt. So P1 plus P2 equal to 200 megawatt. That is first equation. And second equation is that we know that when we neglect the transmission loss, then for most economic load dispatch, incremental fuel cost of each unit should be same. So therefore DC1 by dP1 will be equal to DC2 by dP2. By equating that, we will get one more equation. So we will solve this. So C1 function of P1, it is given in the problem. Similarly C2, which is function of P2, it is given in the problem. Now we need to determine DC1 by dP1, that is incremental fuel cost of first unit. Similarly DC2 by dP2, that is incremental fuel cost of second unit. So if you take derivative of C1 with respect to P1, then we will get 0.01 into 2P1, that is 0.02 P1 plus 30 plus derivative of 10 will be 0. Similarly, dC2 by dP2 will be 0.05 into 2P2, that is 0.1 P2 plus 10, derivative of P2 is 1, derivative of 10 is 0. So we will get these two equations. Now we know that for economic operation, incremental fuel cost should be same. So dC1 by dP1 equal to dC2 by dP2. Now equating these two equations, so 0.02 P1 plus 30 equal to 0.1 P2 plus 10. So rearranging, 0.1 P2 minus 0.02 P1 equal to 30 minus 10, that is 20. So that is equation number 1. And second equation is that total generation, it should be 200. So P1 plus P2 equal to 200. So it is given in the problem itself. So we will solve these two equations. So this is equation number 1 and this is equation number 2. So if you solve equation 1 and 2, we will get P1 as 0 and P2 as 200 megawatt. But here minimum and maximum limits of generation are specified. So what are those limits? So P1, it should be more than or equal to 100 megawatt and it should be less than or equal to 150 megawatt. P2 should be more than or equal to 100 megawatt, and it should be less than or equal to 180 megawatt. Now here clearly P1 equal to 0, that is by our calculation. So this P1 is violating the minimum limit, because it is mentioned in the problem that minimum value of P1 is 100 megawatt. So minimum generation we have to set it for P1 as 100. Now we have to set P1 as 100 megawatt. So remaining 100 megawatt will be supplied by P2, because total generation we require as 200. So finally our load sharing, it will be P1 equal to 100 megawatt and P2 equal to 100 megawatt, because minimum value of P1 we have to keep it as 100 megawatt. Okay, so this is the values of P1 and P2. Now in problem it is also mentioned to determine the incremental fuel cost. Now P1 is fixed at 100 megawatt at its minimum limit. So therefore incremental fuel cost will be determined by unit 2 alone. Now since P1 is fixed to 100 megawatt, therefore incremental cost of power plant will be determined by unit 2 alone. Now how much is DC2 by dP2? So that we have determined, it is 0.1 P2 plus 10. And how much is P2? P2 is 100 megawatt. So therefore DC2 by dP2 at P2 equal to 100 megawatt is given by putting this value of P2 here. So DC2 by dP2 will be 0.1 into 100 plus 10, that will be equal to 20 rupees per megawatt hour. So this is the final answer for incremental fuel cost. So this is the incremental fuel cost, which is equal to 20 rupees per megawatt hour, and generation of P1 and P2 will be 100 megawatt. So I hope you understood how to solve a numerical on economic load dispatch neglecting transmission losses. Thank you.